Welcome to today's Explainer. We're going to tackle one of the absolute most common and honestly kind of confusing mysteries in the entire HVAC world. If you spent, well, literally any time looking at building designs, commercial air conditioning, or engineering blueprints, you've almost certainly bumped into two specific acronyms, EHP and VRF. They get thrown around constantly, and it really often seems like people are talking about two completely competing, entirely different technologies. But are they? Let's dive right into this mistaken identity and clear up the confusion once and for all using the data from our sources. So, picture this. You're looking up at the roof of a modern commercial building, and you spot this massive multi-air conditioning unit sitting up there. Is that an EHP or is it a VRF? Honestly, it's a question that trips up even seasoned professionals when they cross borders or switch from design over to procurement. But here's the ultimate plot twist for you. You are highly likely looking at the exact same machine. They're really not completely different systems. In fact, most of the time, they are literally identical. Section 1. Defining the terms. Looking through different lenses. Okay, so to understand why we have two totally different names for the same exact thing, we need to shift our perspective a bit. See, the confusion doesn't come from competing technologies. It actually comes from looking at the exact same equipment through two completely different lenses. Let's break down where this divergence happens. On one hand, we've got VRF, which stands for Variable Refrigerant Flow. Now, this term focuses entirely on the how, the control technology. It describes the technical mechanism of how the system regulates the flow of refrigerant out to different rooms. On the other hand, we have EHP, or electric heat pump. This term focuses entirely on the what, specifically the energy source. It just tells you that the compressor inside the unit is being driven by an electric motor. So one describes the internal mechanism, and the other just describes a power plug. The crucial point here is summed up perfectly in this quote from our source material. It's a difference in the standard and scope of looking at the technology. I really want you to keep this mental model in mind for the rest of this explainer. We are officially shattering the whole AHP versus VRF myth right now. It is not a battle between two different machines. It's simply a matter of how you categorize them. Are you sorting them by how the system manages its cooling fluid, or are you sorting them by how it gets its power? Section 2. The engineering hierarchy. Which is the bigger concept? If they aren't competing technologies, how exactly do these terms fit together? Like, which one is the broader umbrella and which one is the subcategory? Peeling back these layers is going to make everything click into place. First, let's look at the very top of the hierarchy. VRF, Variable Refrigerant Flow, is the broad, overarching technical umbrella. It's a system that automatically adjusts its refrigerant supply based on the indoor load, which allows it to individually control multiple indoor units from just a single outdoor unit. If a system uses an inverter compressor to precisely control the flow of refrigerant to multiple different zones, it is, by definition, a VRF system. That's your grand technical category right there. Now, here is where it gets super fascinating. To make that VRF system actually work, you have to spin a compressor. And, well, that compressor needs a power source. You generally have two main options. If you choose electricity as your power source to spin that compressor, congratulations, your VRF system is an EHP, an electric heat pump. But if you hook that compressor up to a city gas engine, your VRF system is now a GHP, a gas engine heat pump. See? EHP and GHPs simply live underneath that giant VRF umbrella. And this brilliantly illustrates why the confusion exists in the field today. Because in the vast majority of modern domestic commercial buildings, practically every single VRF system installed runs on electricity. Gas systems are just way rarer today in standard commercial setups. Because of that, the electric-powered EHP and the variable flow VRF are, in physical reality, the exact same box sitting on the roof. The terms have become practically interchangeable on job sites just because the machine they refer to is one and the same. Section 3. The origin story. A half-term used only in Korea. That leads us to a really fascinating detective story. Think about it. If VRF is the overarching technical term, and they're essentially the same machine, why do certain parts of the world, specifically South Korea and Japan, cling so tightly to the term EHP, while the rest of the world has almost never even heard of it? Let's compare the markets. Over on the global market, places like the US, Europe, and Southeast Asia, VRF is the absolute standard. You will rarely, if ever, see EHP on an engineering spec sheet. Sometimes you might see VRV, but actually, that's just a trademarked term by the Japanese company Daikin for their specific VRF systems. Now contrast that with the Korean market. Over there, EHP completely dominates architectural blueprints and government procurement documents. So why the massive regional difference? Well, the answer, surprisingly, has absolutely nothing to do with engineering and literally everything to do with politics and the power grid. Decades ago, South Korea faced massive electricity shortages during the hot summer months when everyone turned on their air conditioners. So to alleviate this summer power peak, the government heavily promoted and subsidized GHP, gas engine heat pumps. Because the government actively created a market strictly divided between gas cooling and electric cooling, the industry just naturally adopted this strict dichotomy. You either bought a GHP or an EHP. And just like that, the term EHP was permanently cemented into local laws, building codes, and daily jargon. Which brings us to a very practical, highly important takeaway for anyone working in this field. If you're an engineer, an architect, or a contractor working on international projects, or even just speaking with global vendors, you absolutely must use the term VRF. Because EHP is largely a localized term born from very specific national grid policies, using it in a global context is just going to cause blank stares and a whole lot of confusion. To speak the global language of HVAC, VRF is for sure your vocabulary word. Section 4. The four-step magic of system operation. Okay, so we've solved the naming mystery and dug into the historical politics behind it. Now let's shift gears and actually look under the hood. Because whether you call it a VRF or an EHP, the mechanical magic happening inside these systems is incredibly cool. I mean, how exactly does one outdoor unit perfectly cool 10 different rooms at 10 completely different temperatures? Well, it all comes down to a secret combination of two specific components, the inverter control and the EEV, which stands for Electronic Expansion Valve. This is the dynamic duo that separates a true, high-tech VRF system from just a standard, old-school multi-air conditioning unit. Let's walk through exactly how they work together in real time. Let's follow the physical journey of the system. Step 1. Shared piping. A single, thick main pipe leaves the outdoor unit and branches out, kind of like the roots of a tree, to every single room. Step 2. Load sensing. The thermostat in each room acts as the brain, constantly comparing the current room temperature against what you actually set it to. Step 3. Now this is where the magic happens, EEV control. That little electronic expansion valve in the room's ceiling unit physically opens or closes by tiny, tiny fractions of a millimeter, letting in the precise amount of refrigerant needed just for that specific room. And finally, step 4, inverter response. As all those little valves open and close across the entire building, the outdoor unit feels the pressure change and its inverter compressor dynamically speeds up or slows down to perfectly match the total demand. It's an incredibly elegant, responsive loop. Section 5. Final summary. The mistaken identity solved. The responsive variable flow of the refrigerant driven by an electric-powered compressor is honestly a masterpiece of modern engineering. But it's a masterpiece that has unfortunately suffered from a bit of an identity crisis over the years. Let's bring this all together and lock in your new mental model with an ultimate cheat sheet. For VRF, the concept is control technology. Its exact opposite is those old-school single-flow on-off systems, and it's the global standard. Now for EHP, the concept is the energy source. Its direct opposite is the gas-powered GHP, and it's a term primarily used in Korea and Japan. Bottom line, VRF is the global language of the technology, while EHP is the localized language of the power source. Which brings us to a final, slightly provocative thought to end our explainer today. You know, we like to think of engineering and technology as universal, highly objective languages. But as we've clearly seen today with AHDP and VRF, that's not always true. It really makes you wonder how much of the other daily technical jargon we use is actually secretly shaped by invisible local government policies and energy grids of the past. It's definitely a fascinating thing to think about the next time you're staring down a spec sheet. Thank you so much for joining me for this analysis. Keep questioning the details, keep looking at the sources, and I'll catch you in the next explainer.